This video is over lesson 88, multiplying and dividing rational expressions. So ladies and gentlemen, when you hear the word rational expression, remember you should be thinking this is somehow related to rational numbers. And a rational number, as I hope you have memorized by now, is any number that can be rewritten as a fraction using integers where the denominator is not zero. So anytime in mathematics when we say something about something being rational, especially a polynomial or an expression being rational, we're thinking fraction. So we're looking at multiplying and dividing fractions with polynomials in them today. Before we do that though, the thing is, ladies and gentlemen, what you learned in the past, what was true before, is still true today. So that the foundational skills you learned back in the past, we're still going to be using, we're just going to be using in slightly different and more advanced ways. So when I talk about multiplying and dividing rational expressions, let's just start with multiplying and dividing rational numbers. So like 4/5 times 2/7. Now hopefully you're already ahead of me and you're already remembering that when we multiply fractions, we just multiply across. So just as we're doing that here, in a moment when we get to our rational expressions, we will do the same thing. We'll multiply numerator with numerator, denominator with denominator. Likewise, when we divide rational numbers, what we used to do is what we're going to continue to do. So what we used to do was we used to convert this into multiplication by making the second number its reciprocal. And now here's a good time to just remind you that just as before we could reduce before multiplying, we're still going to be able to do that now. But the key is you've got to have things expressed as products before you can do this. So if we finish this off, then I would get 14 over 5. And I'm good right there. That's the point. So ladies and gentlemen, what I'd like you to do for me now, please, is to go find your math book and open up to page 579. 579. And we're going to use some practice problems from lesson 88 to help us go through this today. So here we go. I'm going to skip a space there. And I'm going to copy down the first problem. So 4z to the 5th power q, I don't know what I did there, q to the 8th power over 14 q z to the 7th power times 14 q z to the 4th power and over 3 q to the 4th power z. So ladies and gentlemen, before we tackle this and actually multiply it together, reduce. So one of the things that stands out to me the most is the 14s. 14 and 14 obviously will reduce down to 1s. And now let's just pick apart our q's and our z's here. So I see a q down here and a q to the 8th up there. So that means that'll become q to the 7th. Make sure that's a 7. Then I've got z to the 5th and z to the 7th. So those will be gone. And then I'll still have z squared left in the denominator. If I look over here, I see, q to the 4th and q to the 7th. So that'll be completely gone. This will become q cubed. And then I'm looking here, I see the z and the z to the 4th, so that'll be gone. This will be z cubed. And then finally, z squared and z cubed. We'll just leave a z up there. So let's just double check down here. I've got a 1, that's gone, that's gone. I got a 3, that's gone, that's gone. So 1s don't reduce, so can I reduce 3 with anything? Nope. So this is reduced as it's going to get. Therefore, let's go ahead and multiply. So up top, I've got a 4 times 1, 4. I'm going to go alphabetical, so I'm going to look at my q's first. So I got a q cubed, and I got a q. So that'll be q to the 4th power. Those z's are gone. That's a single z left over. So that's my numerator. In the denominator, start with my numbers. So 1 times 3 is 3. My q's are gone there. They're gone there as well. My z's are gone here, and they're gone there as well. So just 3. So, just to make it look nice, not that it mathematically changes anything, but I'm going to put that denominator in the middle. Just makes it look nice. So my final answer there is 4 q to the 4th power z all over 3. Another way to do this, if you're looking at this and you're feeling a bit overwhelmed, another way that you could tackle this, let's get it copied real quick here. 14qz to the 7th times 14z to the 4th. Oh, I forgot a q in there, didn't I? q z to the 4th, there we go, all over 3 q to the 4th z. So another way that we could go ahead and try to tackle this right here would be to go ahead and just reduce the numbers to start with. So if I reduce my numbers, then let's put it together. So if I put this together, I'll have a 4 up top. I'll have a q to the 9th power. And looking at my notes from last year, I have to wonder a little bit if you guys don't have this q in your book. If you don't, go ahead and add it in just so that your notes are the same as mine. But I kind of wonder there. So anyways, moving on. So z's, I got 5 z's and then 4 z's. We'll make a total of 9 z's. And then all that will be over a total of 1 plus 4 is, oops, sorry, I forgot my 3 out front. But 5 q's and then 8 z's. So if we do it this way, we've got a lot less reducing going on here. And now that the letters are all combined, it should be fairly easy to simplify them. So we can see we're going to have a 4 up top. We know that 5 of these will cancel 5 of those, so there'll be 4 q's left up top. We know that 8 z's will cancel with 8 z's, leaving just a single z up top. So my q's are gone, my z's are gone. It's just the 3. So ladies and gentlemen, that's just another method. You can see there it might require a little bit more work, take a little more space on the page, but it's a little less messy because there's less being crossed out along the way. All right, let's go ahead and move on to letter B. So B, we have 5x squared over 7y squared times 4x squared over 9y cubed. So variable-wise, nothing's going to cancel there. That's at least somewhat convenient. Number-wise, 7 doesn't reduce with a 5 or 4. 9 doesn't reduce with a 5 or 4. So really, just multiply here. So 5 times 4 is 20. X squared times x squared is x to the 4th. 7 times 9 is 63. And y squared times y cubed is y to the 5th. So B was pretty easy. C, we've got 6 over 2x minus 18 times the quantity x squared minus 6x minus 27. So as I work this one out, one of the things that we're going to want to do anytime you've got something more than a monomial is you want to factor. So we just want to factor things here. So when I look at this, I've got 6 over, And then I can factor a 2 out of that, leaving me with x minus 9. And then times, and I'm going to throw this over 1, just to turn it into a fraction as well. And so now I'm looking for something of the form x squared plus bx plus c. So remember our plus c here, it's got to be something times something is a negative 27. But when I add those two numbers together, I get a negative 6. Well, 27 really doesn't have a lot of factors. So it's probably a 9 and a 3, especially since a 9 and a 3 can together make a 6. So particularly if I make it a minus 9 and a plus 3, that'll multiply together to make a negative 27, add together to make a minus 6. So x minus 9 and x plus 3. Now that we have things expressed in terms of multiplication, we can reduce. But remember that parentheses are going to say treat this as one object. So I cannot reduce this 9 with that 6. I cannot reduce this 9 with that 3. Because this is not just a 9, this is x minus 9. However, I can reduce my x minus 9 with my x minus 9. I can also reduce my 2 with my 6, make that a 1 and that a 3. And now we see all 1s in the denominator, which means we will no longer have a fraction for our answer. So I'm going to line up a new equal sign with my old one. And so what I'm left with is a 3 on the outside and an x plus 3 on the inside. Now, since that's simple enough, I'm going to go ahead and distribute that. However, either one of those could be our answer. Let's move on to D now. 8m plus 6m squared n all over 12 times 8m over 24m plus 8mn. So once again, ladies and gentlemen, anytime you have something more than a monomial, we need to factor. So looking at my first fraction, the numerator, I can pull a 2 out of both of those, and I can pull an m out of both. So that will leave behind a 4 plus 3mn. And this is over 12 times 8m. And then I can pull an 8 out of both of those and an m out of both of those. And so that will leave behind a 3 plus n. So if we go ahead and reduce before multiplying, I'm looking here and maybe I reduce my 2m with my 8m. So the m's will cancel. The 2 will become a 1, the 8 will become a 4. From here, maybe I reduce my 12 and my 8. So 12 will become a 3, 8 will become a 2. And then I can go ahead and reduce my 2 and my 4. That'll become a 1, that'll become a 2. And I'm looking at anything else. I've only got a 3 here. So 3 will not reduce with the 1 or the quantity or the 1 or the m. 2 will not reduce with the 1, the quantity, the 1, or the m. And then this quantity does not reduce with that quantity, which means that I'm done. I need to go ahead and just get my answer. So I'm going to come down here. And so what's left up top is I have the quantity and an m. So I'm going to put the m out front. And then in the denominator, I got a 3 times a 2 will give me a 6. And then that quantity. So 6 times 3 plus n. And that, ladies and gentlemen, can be our answer. All right, moving on to E. We're going to start dividing here now. So skip line E. With E, I have 8j squared k to the 7th power over 15 k to the 7th j to the 4th power. And I'm going to divide that by 6 j cubed k over 5 k j to the 6th. Now remember, ladies and gentlemen, we can only reduce before multiplying, so I cannot reduce anything in this numerator with anything in that denominator because we're not multiplying these two fractions. However, I can actually still do some reducing here. You can always just reduce a fraction. So in particular, and again, I'm looking at my notes and I'm thinking that you guys have a different problem than I do here for E. My notes from last year are saying that this actually should be a k to the 4th. So my notes from last year are saying that this is j to the 7th and k to the 4th. So I think my book is wrong. I think that's what you guys have in your book. If not, let's make this change. Let's go with that actually. So anyways, as I was saying, we can reduce it within the fraction here. So I got 2 j's on top, I got 7 on bottom. So that's going to be a total of 5 left over on bottom when they cancel. I have 7 k's on top, I got 4 on the bottom. So those 4 will be gone. Up here, there'll be 3 k's left over. Looking over here, we have a k on top and we have a k on bottom. So those are just going to cancel and be gone. But with 3 j's and 6 j's, those will be gone, and we'll still have j cubed left on the bottom. So that makes our fractions a little bit simpler. So let's go ahead now and change these into times the reciprocal. So the first fraction is going to stay what it is right now, so it'll be 8. The j's are gone, but I have a k cubed. And then that'll be over 15 j to the 5th, but the k's are gone. I'm going to do times, and now the reciprocal of this. So I'm going to put my 5 up top. We got a j cubed, j. And then on bottom I'm going to have a 6, and actually both the variables are gone. It's just a 6. Now that this is multiplication, we can go ahead and see if we can further reduce this. So in particular, I see my 8 and my 6. That'll be a 4 and a 3. I see this 15 and this 5. So that'll be a 1. That'll be a 3. I see a j to the 5th and a j cubed. That'll leave a j squared down here. And looking it over, that's as far as I can go. So go ahead and multiply it, and we got our answer. So 4 k cubed is what's left up top. And on bottom, I got 3 times 3 is 9, and I got a j squared. So 4k cubed over 9j squared. I've run out of room, so I'm going to go ahead and flip over and go to the back. So f, I've got x squared plus 7x plus 12 all over x plus 5. And we're going to divide that by x plus 3. So when I go to work this out, we're going to try to factor anything that we can, anything that's more than a monomial. So up here, again, this is an x squared plus bx plus c form. So is there anything times itself that's 12? But when I add it, it's 7. And hopefully you're saying yes, x plus 3 and x plus 4. 3 times 4 is 12, but 3 plus 4 is 7. In the denominator, x plus 5 cannot be factored. You could put parentheses in there if you really want to, or you can just remember to treat that as one quantity. Now here, remember that expressions like this are always themselves over 1. So if we take a reciprocal of that, then it'd be 1 over x plus 3. Likewise, because of the plus here, we're going to treat that as a quantity. So x plus 3, the quantity, will cancel x plus 3, the quantity. And that's as far as we can go. So my answer, x plus 4 over x plus 5. Moving on to G. For G, we have x squared plus 5x plus 6 over x plus 2. And then we're going to divide that by x plus 3 over y squared. So I'm going to factor. I'm also going to change this to times the reciprocal. So if we factor this numerator here, what times what is 6? That when I add them is 5. Well, that's easy. X plus 2 and x plus 3. 2 times 3 is 6, but 2 plus 3 is 5. And then in the denominator, I've got an x plus 2. Now, before I even get to the rest of it, boom, boom, we know those are going to cancel. So that's nice. All right, now times the reciprocal of the other fraction, so times y squared over x plus 3. And now that this is multiplication, I can see my x plus 3 and my x plus 3 are going to cancel. So if they're all gone, that means that my answer here really is just y squared. All right, and last example, H. Tran makes a profit of x squared over 2x squared plus 10x for each ticket he sells. What is his profit in terms of x if he sells x squared plus 9x plus 20 tickets? All right, so, well, if you know how much each ticket costs and you know how many tickets there are, we multiply those to find the total profit. So I'm going to take my x squared over my 20x squared plus 10x, extend my fraction mark a little bit, and multiply it by my x squared plus 9x plus 20. Make sure you use the parentheses there. If you don't, you're not expressing this correctly, because the order of operations would tell you only to multiply the fraction with the first term. So you need to group it in parentheses so that it is one term, one group. All right, now let's go ahead and do our factoring. So on the bottom, I can factor out a 10x out of both of those. That'll leave behind a 2x plus 1. And then if we keep going here, this will be over 1, of course. And so then what times what is 20? That when we add them is 9. Well, of course, 4 times 5 is 20, and 4 plus 5 is 9. So x plus 4 and x plus 5. So now if we reduce as much as we can, ones do not reduce, none of my quantities reduce, so it's really just an x with that x squared, which means that my answer will be x times x plus 4 times x plus 5 all over 10 times 2x plus 1. So that one doesn't simplify very much, but who said it had to? So that would be our answer. And that, ladies and gentlemen, is the end of this lesson.